So I think last time we went over pulse width modulation to drive a DC motor using Arduino Uno. This was the circuit. Today we're gonna look at the analog input section of the Arduino Uno, the ADC, the analog to digital converter. Gonna be looking at the potentiometer, and we're gonna slowly build our own voltmeter using an Arduino Uno. So I can delete some stuff here. Button is that shift. If you hold shift, you can drag and select multiple components. So in order to understand the Arduino analog inputs, you will have to understand the ADC, the analog to digital converter. I'm going to use the whiteboard for this. Alright, so we have 0 to 5 volts here. Now if we have a analog to digital converter, it will sense an analog signal here, and it will output a digital signal here. Now this is a 2-bit ADC, which means that we can have 4 different codes. So 00, 01, 10, 11. And if we have voltage like this, let me move this out of the way for now. So let's say this is our analog voltage. We can split that into 4 different codes if we have a 2-bit ADC, which means that, let me use a red pencil here, we will get something that looks like this. So any voltage that falls between this range will have the code 01. Let's split this up into 4 parts as well. So half is 2.5 volts, 1.25, 3.75, right? So in this interval right here between 2.5 and 1.25, the ADC is going to give us the code 01. Now there's a problem with this, is that this is quite a wide range for the same code. So if we're using our Arduino Uno and we're reading a 01, we know that it's a voltage between 1.25 to 2.25, but it could be anything in between, so it's not very precise. We don't know what the actual voltage is, we just know it's in between this range. But if we add one more, so this is a 3-bit ADC now. Now we have the codes. Is there a way to faster erase this stuff? Better be. Actually, we need that. We don't need this. We still have our voltage, but we can split this up into 3-bit system now. So that will give us the code 000, 001, 010. Let me do this a lot more tightly spaced. Okay, so now we have 1, 2, 3, 4, 5, 6, 7, 8 different codes for this. 1, 2, 3, 4, 5, 6, 7, 8. Excellent. Now this looks, let's actually draw this out and see what, now you see we've split this up into a lot more codes. So if we get, let's see here. So we're in the code 010, and it gives us a value between 1.25 and, let's just go with 2. So we've increased the preciseness of this ADC, and the more bits we add, the better this becomes, this staircase, the closer it follows this analog line here, and the more confident we can be in our voltage reading. So the Arduino Uno has a 2 to the power of 10 bit, what's that? 1024 bit ADC built into the analog inputs. So we take 5 volts, we divide out by 1024, and that's going to give us how big each step is. 5 divided by 1024 is 4.88 millivolts per step. So this is how sure you can be of your voltage reading. It's going to be within a range of 4.88. So let's say our value is 2, then that's what your ADC gives you. Then you can be sure it's between 2.488 or 1. Whatever that is, 96. So it's pretty good. It's pretty precise. You can be decently confident in your voltage reading. So the reason why I said that is because whatever voltage you apply on the analog input, your Arduino is going to give back. So let's go to the code to actually show this. you do analog read. You put in the pin number. In this case, let's just go with A0. And then you close it. This is going to give you a value between 0 and 1023. So let's build a circuit and try this out. I'm gonna need a breadboard. Let's go with the small one. I'm gonna need a potentiometer. I haven't gone over how potentiometers work. I guess I can do that really quickly. Across terminal 1 and terminal 2 is the entirety of this resistance. So in this case it's 250 kilo ohms. So you can think of this as just a resistor. Let's do what was it, 250? Yeah. So if you wire something from terminal 1 and terminal 2, let's just do that for the sake of argument. This is the same thing. And even if I turn the wiper, nothing happens, right? So across the two terminals, it's always going to be the same resistance. Now let me try it on the wiper. Okay, see, now we're changing. So now it's the full resistance. Now, okay, it's 0, so the LED just explodes. Let's just keep it around here. Cool, right? So when you put it on the wiper, you can change the resistance. It's kind of nice, kind of handy. And let's start inputting some voltages into the Arduino and see what happens. So with our potentiometer, we're going to create a voltage divider. I haven't gone over that in this series. Maybe I have in another playlist. But I'm hoping you know kind of the theory behind the voltage divider. Okay, let's feed this into A0. I'll press 3 or I press 4 to color this yellow. Alright, so yeah, we've created a voltage divider. When we turn this potentiometer now, the voltage here is going to change between 0 to 5. And let's catch that value. So first let's define A0 to be an input. Then let's tell the microcontroller that we want an integer voltage to be defined, and we can put it equal to 0. And now we set that voltage equal to whatever we read on this. We have to display this somehow. So let's also tell the microcontroller that we want the serial. We give the baud rate to be 9600. And let's just do Serial.println, so we get a new line every time it prints. And I want to print the voltage, that's all. But I would also like this to happen not immediately. So let's add a little delay here. Let's go with 1 second. Press the serial monitor. Okay, it gives us 1023, which means that's 5 volts, right? That's the maximum, that's the code for, yeah, 1024, it's up here. And what happens when I turn the pot? Okay, see, it's dropping to 0. Okay, awesome, so we have a voltage divider with our potentiometer, and we can read, the ADC is giving us values, but these values don't tell us much, so we have to transform this value. So let's rename this into ADC voltage. Right, so this is the code we get when we read off of the A0 pin. So let's transcribe that. We've got 0 to 1023 and 0 to 5. So if we plot that, let's do the binary or the code here. Let's do the voltage here. It's a line that goes like that from 5 and to 1023. Now we just need to find the slope. So if you remember, the slope was, okay, it says 4.88. So we might have to turn this into a float in order to store our value. Let's just do voltage is equal to the code. Alright, so let's keep 4 significant figures. just do it like that. Alright. Okay, let's see what this gives us. Nice, so it's 5 volts. Half is 2.5 and 0. This is cool, right? We can confirm this with a multimeter. Let's put that on the wiper and let's put that on ground. Okay, let's start. So 2.4. Alright. 3.80. Nice. 4.60. 1.40. Cool, right? We just built our a voltmeter using the Arduino. And we're gonna take this one step further. We're gonna add, is there an LCD here? We're gonna add an LCD display, and I'll go over I2C as well.